Hey people, a couple of people have asked me separately to do this question for them. This is question 3 from the random circuit analysis questions that I gave you last week. 2 people have now asked me to get through this one. So I'm going to do the entire thing and give this video to everybody. So this was the circuit, 12 volt, excuse me, 12 volt battery, 12 volt power source. Current goes out. I'm just going to consider conventional current. I'm going to go the conventional way instead of electrons. So current comes around here, goes through this, and then splits here. Now these two are in parallel because the current can either go through that one to get back, or it can go through that one to get back. So R1 and R2 are in parallel. That's the test for parallel. No matter how it looks, no matter what the shape is, if the electricity can either go through one or the other, they're in parallel. All of the electricity has to go through this one, right? It's got to go through there. There's no other way to go. And if you consider it backwards, it's the same thing. You get here and the electricity is either going to go through there, but it has to go through R3, or it's going to go through R1, but it has to go through R3. Now just hang on a second. I have a tortured cat. Okay, having placated the tortured cat, let's move on. All right. So having seen that, they're parallel with each other, and that collection, that parallel section, is in series with this because electricity has to go through there and then through the parallel section. So they're in series, one after the other. Tortured cat is just going to have to be lived with. All right. And they wanted us to find pretty much everything. So this was the question. Right? So they gave us this. We've already got what's in red. Right? And they asked us to find the voltage across all the resistors, the current through all the resistors. They gave us the resistance. They wanted to find the power through everything and the totals. So let's do it. You nearly always start with finding the totals, right? The first thing you find is hardly ever the current through that or the voltage across that, right? It's normally the totals, and the reason for that is because you're given the total voltage and you can calculate the total resistance using those resistance formulas. So that's normally where you start. So this is what we're going to do. Question 3, find the totals. I'm just going to get this out of the way for a second. All right. Okay, totals first, right? V, I, and R. And we've already got the voltage. They gave us that 12 volts. The total resistance, this is how it's done. So the 220 and the 130 volt resistors, pardon me, the 130 ohm resistors are in parallel, those guys, R1 and R2, right? So to find the total resistance of this parallel section, not counting that yet, just these guys, this is what you do. Use the old parallel formula. And the answer comes to 81.7, right? 1 over 220, 1 over 130, right? Flip the answer, 81.7 ohms. Excuse me. Now, by the way, before I go any further, when you look at the answers that I gave you for this, they are slightly out from what I've done. That's quite okay. The difference is going to be down to my calculators rounding out, or the number of decimal places that my calculator goes to in calculations versus the number of decimal places that their calculator went to. So if you get an answer and you're out by less than about 2% or 3% or something, and it was a reasonably complex calculation, you're probably right. The only difference will be calculator differences. So this is fine. All right. So that's the total resistance of the two that are in parallel. Those two combine for a resistance of 81.7, right? And that's right because in parallel, the total resistance should be less than either of them, and it is. But that is in series with the 470 ohm resistor, so the total resistance of the whole thing, you just add those two up because they're in series. So the grand total resistance of the entire circuit is 551.7 ohms, and that's what I put right there. All right. So we're all about finding the totals, remember. We've got the voltage, it's 12 volts. We've now got the R, we can find the total current. And here's how you do it. Simple as pie. V equals IR, and again, as always, I say this a lot, the V, the I, and the R have to be for the same thing. And this is for the whole circuit. All of the voltage, all of the resistance gives you all of the current. All right. Now, The answer that they gave was in milliamps. I tend to sort of leave it in amps because you have to put them in formulas in volts and in ohms and in amps, not in kilovolts or millivolts or milliamps or whatever. So if you know that there's like a part B and C and D and E to come in the question, just leave it the way it is for now, because if you convert it to milliamps, you're probably just going to have to convert it back again to amps in part C of this question to stick it in another formula. So worry about converting it to milliamps or whatever, only if they ask for it. If they don't ask for it, that's the answer and that's correct. But if they ask for it in milliamps, go back at the end of doing everything and then convert all of your answers to milliamps or whatever if they ask for that. Okay, I'm just leaving it the way it is. Okay, so they're the totals. Now let's get down to all of these single parts. I'm just going to fill in a few things here. So the total current is 0.0218 amps. I'm just going to write this in amps even though it said milliamps. Okay. Haven't got any of this stuff yet. Getting there now. Going to lose this. All right. Now let's just get back to this circuit. So we now know that the current that's coming out of here, the total current, is 0.0218 amps. So it's going to be 0.0218 amps all the way around here. It's going to split. We don't know what it splits into, but those two currents that are going that way and that way are going to add up to this. Right? And they're going to split. Some are going to go through here, some are going to go through here, and then here they're going to join back and they're going to be 0.0218 amps again. So we know the current in this resistor. Right? So that's what we're doing next. The voltage across R3. Right? We know the current in that resistor R3 is the same as the total current, 0.0218 amps. I think the answer that they gave in my document was 21.75 milliamps. Right? This is 21.8 milliamps. Okay, so V equals IR. We've got the R, we've got the I. We can find the voltage that's lost through that one. So here it is. 10.25 volts. 0.0218 times 470, 10.25. So it starts with 12 volts, and from there to there, 10.25 of those volts is lost. All right, let's put it in. 10.25. Got it. Now let's take the other two. All right. Okay, so to find out the voltages across each of the other ones, you now know that you started with 12. We lost 10.25 there. And whichever way the electrons are going to go from here, whether they go this way or that way, right, or conventional current, because I'm going backwards now, this way or that way, we know that it's only got 12 minus 10.25 left to lose. And it's going to lose all of it through one resistor, because no matter which path it takes, it's only got one more resistor to go through. So the voltage across that resistor or the voltage across that resistor must be 12 minus the 10.25 that it's going to lose across this one. And that comes to 1.75. So both of those voltages are 1.75. Filling it in. 1.75 volts, 1.75 volts. There's 12 volts coming into the circuit, so 12 volts has to leave. Right? 1.75 there, 10.25 there, adds up to 12. Same the other way, 1.75, 10.25. Okay, pardon me. Current. What's left here? We've just got a couple of currents left, and then we'll worry about power in a minute. Current in R1, current in R2. And again, V equals IR is going to get it for us. But as long as the V, the I, and the R are for the same section, we're cool. Current through R1, okay. That's the resistance of R1. We now know the voltage across R1, V on R. 1.75 divided by 220, answer is 0.00795 amps. 0.00795 amps. Similar deal for R2, exactly the same thing. Voltage across R2 is 1.75. We found that out before. Resistance is 130. Divide it, comes to that. 0.0135. 0.0135 amps. Okay, now for power. Last cab off the rank. Power is V times I in every case. So again, for each of those three resistors and for the total, we just have to find V times I. And we've got the V's and we've got the I, so we're just going to go that times that equals that, that times that equals that, that times that equals that. Okay? And that times that equals that. That's all we have to do now. And the answers go like this. Cross R1, those two come to 0.0139 watts. Again, get the units right. R2, not going to bore you, 0.0236. Okay, not going to bore you more. And finally, R3, 0.2235 watts. All right, one more to go, the total. And that comes to, sorry, I've gone off scale here. 12 times 0.0218, and that comes to 0.2616 watts. And again, these answers here will slightly differ from the answers that were on the other one, just because of a calculator rounding difference, but they're still all considered correct. Feel free to email me if you have any more questions about this, but that's question 3.